In example 3, I'm going to deal with part A and part C together, and then I will answer part B at the end. In part A, I'm asked first of all to find f of g of x. Now, as we've done before, what we're going to do is we're going to identify the graph, the function that we are substituting into, and we're going to identify what we are substituting. G of x has to go in the place of x. So the g of x expression must go everywhere where I see x in the f of x graph. As this was a split function, I need to replace it over here and over here. And you will notice, as I have a restriction on my domain, the g of x, x plus 2, must replace where I had x in my domain as well. In other words, the f of g of x graph is going to look as follows. First of all, just replacing x with x plus 2, I get x plus 2 plus 1. Continuing with this part of the split function, my x values have to be x plus 2 greater than or equal to 0. Now going to the second part of my split function, where I saw an x, I still write x plus 2, but now it's minus 1, and where I see an x for my domain, I have to replace that with my g of x, which is x plus 2, and that now is less than 0. All that remains now is for me to simplify my two expressions. And simplified, my f of g of x graph is going to be as follows. X plus 2 plus 1 is x plus 3 for all the x values greater than or equal to minus 2. And then for the second part, I get x plus 1 for all the x values that are smaller than minus 2. As I now want to work out f of g of 2, I actually am trying to find f using the g graph at 2. So if I take g of 2, I'm going to get the answer on my new function when my x value is going to be greater than or equal to minus 2. As 2 is greater than or equal to minus 2, the part where I have to substitute g of 2 is going to be over here. In other words, I now have an answer. So f of g of 2 is going to be 2 plus 3, which is going to be equal to 5. Going back to my very first step, if I had not known what f of g of x had been, and I needed to know f of g of 2, I would have taken 2, I would have substituted it in the place of x on the g graph, which would have given me 2 plus 2, which is 4. 4 is greater than 0. So then I would have taken the 4 and substituted it into the first part of my split curve for f of x. And in the place of x, I would have said 4. In other words, I now have 4 plus 1, which once again would have given me the correct answer of 5. In part B, where I now want to work out what the answer is for g of f of x, I'm looking for g of f of x. Now this is telling me that in my g graph, where I had an x, I must put all of f of x. You can see, as there are no restrictions on my domain, I'm not going to change my domain from f of x. In other words, for g of f of x, I'm going to get my answer as follows. I'm going to get all of f of x plus 2, which means for the first part, I'm going to have x plus 1 plus 2, but x is still going to be greater than or equal to 0. Or I'm going to have x minus 1 plus 2, and that is still going to be for when x is less than 0. So as I did with the previous example, all that remains now is for me to simplify these two expressions. I'm going to get x plus 3 for x greater than or equal to 0, and I'm going to get x plus 1, but this time for when x is going to be less than 0.